For those that might not know me already, my name is Bill, and I'm a freshman here at RIT. I love Windows internals, everything about that, and I've spoken at DEF CON and Recon. So we're going to start off with some OSINT, some fun times. So the strategy was initial enumeration is showdown, because no scanning RIT networks, that's bad. No one here scans RIT networks for sure. And so what you can do is, as a student, you can sign up for their little educational package, and they'll give you a lot of scan credits so that you can use their CLI, you can export results, you can do all that. So if you're a student, you can definitely sign up for this, and for example, I got like 65,000 scan credits. And so what this allows me to do was scan the OpenStack subnet. I found OpenStack through the SSL certificate, just looking for RedSec, and it was the first result, stack.redsec.cloud. And so now I knew where the OpenStack was being hosted, and I knew where ISTS was being hosted as well. So the first thing I noticed in the subnet was this little RDP open called ScoreStack Wind. I'm not quite sure what that is still, but I found out this ScoreStack name because someone registered an SSL certificate for ScoreStack.ists.io. And so I knew this was a new project. When I went to it, it was Kibana. So I knew that this was going to be definitely something related to ISTS. And I was keeping an eye out for anything named ScoreStack. So it actually turned out better than I expected, because a week before the competition, someone put up the cyber range on the ScoreStack machine, and I actually caught it. And I pulled down the site. I didn't do anything. I didn't interact with it because it's just OSINT. But someone opened it on like port 8000, and so that gave me a little bit of an advantage because I knew what to expect. I also correlated it to the topology that I was given, the pwn sauce, that was called cyber range. And so this was probably the best OSINT leak I had in the competition, and it helped me prepare for injects that would occur during the competition. The next thing I detected was the secure hosting subdomain. There wasn't much here. I knew it was custom, and that it was definitely something to keep an eye on for, but I couldn't really do much because it was only a login page. There was nothing really public. But something that was surprising to me was that pretty much every Flask instance that was running related to ISTS had debugging enabled, which is definitely a security risk. And so I just found that a little bit surprising. But besides that, the secure hosting didn't really have much. The next thing I found was Graybay. This was hosted a day before the competition on Friday. Someone put it up, and I quickly caught it. This was on one of the other IPs, not ScoreStack. Here, the interesting part was the assets, because it told me, for example, there like an asset that was being referenced by the HTML was like revert.png. So all that stuff, I kind of got the idea this was the white team store. And so now I knew that like what it would look like, what I should expect, and what items might be on the store itself. And so this wasn't that big of a leak because it was only on Friday, a day before the competition, so it's not really that useful. But it was definitely interesting to see anyways. Something else I accidentally found was, so I saw this Minecraft server running on like a weird port, like 25564, and I was like, okay, I don't know why, who's hosting a Minecraft on OpenStack? And so I decided the best idea would be to join the server and say hi. There's people on it, actually, and so I actually like joined the server, and I was like, hi. I asked, what's your major? Because this was on an RIT IP, so I assumed it was RIT students. They're like, I'm in high school. I was like, oh, okay. And then one of the people was like, oh, I'm going to guess you're one of Simon's friends. And I was like, Simon? Could that be, could that be our boy? And so what I did was I quickly asked him, are you running a Minecraft server? And he said, yes, why? And I said, who's it for? And apparently he's hosting it for his brothers and his friends. So that was a nice time explaining to him how I found his Minecraft server. But it didn't really matter that much anyways, because the cyber range, I already found it like 15 minutes before this. So it wasn't that big of a deal. But it was just so like amusing to see that I found one of the black team members' Minecraft servers while searching for the ISTS leaks.
So I should point out that range that you're scanning against.
I'm not scanning anything.
It's shown in it.
Yeah. Okay. Yeah. So that range though that is being scanned is not just
okay.
OpenStack.
I know.
That's the entire RIT stuff.
Oh, well, I only did /24, but yeah.
That's the entire RIT.
Yeah, there's a magclave on there.
I know. That's why I didn't scan anything. Only showdown.
Yeah, OpenStack doesn't have a dedicated IP is what we're saying.
Yeah.
It's just eating from RIT.
We don't care if it's your scanning or something. I don't care.
Okay.
The scan. That did happen.
Yeah. All right.
There's more than trust.
I understand, and I appreciate your concerns. But again,
I'm not saying that you guys don't give yourself.
Phil, you're good.
okay, I'm gonna continue. There's time for questions in the end, so don't worry, guys. All right, so next up is the CTF before we get into the Windows stuff, the spicy stuff. So just a few solutions. So for Windows challenges, to crack me 0x01, when I opened it, it said enter code. I entered something random. It said hack harder, try again. And so I decompiled the assembly and found that there's two paths it would take depending on whether or not the key you entered was valid. And so one would actually print the flag, and one would just print the hack harder, try again. And so the simple idea I had was just to NOP the check, the jump where it checks whether or not what you entered is correct. So it would just go to flag. And so when I just did that, I NOPed it out, and it was already in, like as a string, the flag was there. I assumed that they might have done a little bit of like obfuscation on it, but no, this was straight up the flag. It was in the code as well. And so yeah, it was pretty simple. You just NOP the code checking the whether or not what you entered was correct, and so it was pretty simple to get to that solution. The second crack me was, again, pretty simple. It was just UPX encoded, and then when I unpacked it, next thing I knew, the flag was there, and I tried it, and it was the correct one. They didn't really do any obfuscation on the flag itself. And so the next challenge was the sandbox runner pwn, which I found was really interesting. So it just asked me, what's your favorite number? And then it would just say welcome and ask you to type in either input or run. What I found was, though, that you could type input and run all at once. And so what it would do is it would first ask you for input for your code, what you wanted to enter, and then immediately after it would run it. So the simple solution there was just to send input run, send shellcode that would launch a shell for me to access, and then just send it straight there. And so this was a pretty simple solution, and I got a shell on the sandbox runner CTF box. But weirdly, when I just tried to enter the flag, I got the flag from flag.txt. It said incorrect. I was really a little bit surprised here, what's going on here. And so I was talking to Stuart, who ran the CTF. And so what UVA decided to do was change the flag file so that it would contain something legitimate. And just, I guess, trying to mess with other teams. They were the only team that solved it. That's how you chase it back there. And you could see that it was written to just during the day that the CTF was up. So, yeah, no, they decided it would be funny to just overwrite that flag. All right, Windows preparation. Some spicy stuff. And so, first of all, on the Friday before the competition, I learned that WinRM was a scored service. It wasn't in the packet. And so I was not going to get 8 hours of sleep that night. And so the original plan was just to completely disable command prompt and PowerShell because I don't need those. At least I don't need them after the initial deployment. And so what the new plan was I had to think about was how am I going to let command prompt run, because that's what WinRM uses to execute commands, while also making sure that no one can just run commands all they want. And so what I came up with was a solution is I'd have a binary I just called it command host, and what it did was when it was started, it would check who started the process. And so when WinRM executes a command, the process that starts it is actually called WinRS host. And so what I did was I checked whether or not the calling process, the one who started the current process, was WinRS host, and only then did I forward it to command prompt. And so what I did was I replaced the original command prompt binary so that whenever someone executed a command, unless it was WinRM itself, it would not run that command. And even if it did run the command, everything was logged, and so this allowed me to track what commands were being run through WinRM and what I needed to look out for. It told me, who started the process and the name of that process as well. So it was a really good data source for finding who's trying to execute just normal command prompt commands. And so then before I go to the next section, I want to give a little bit of background for stack walking. It's a little bit more technical. And so whenever a program calls a function, the address after the call instruction is pushed on the stack. This is called the return address. And so what happens is stack walking is the technique of actually going backwards on the stack and finding out what led up to the function you're currently in. So you can find out what functions were called to get to where you are now by looking at the return addresses leading back all the way to the start of the thread. And so for ISTS, I decided to make a little platform, threat detection platform. It's called Peacemaker. And so Peacemaker is a Windows kernel mode utility, and it's designed to detect a variety of methods commonly used in malware, creating remote threads, detecting hidden code. And so compared to a normal antivirus, what it does, it targets the techniques themselves, not instead of just trying to target signatures or hashes that you might have known before. And I started this soon after ISTS registration because I wanted to, it was a very big project and I wanted to have enough time to complete it. And so what Peacemaker actually detects, so it detects hidden code by actually stack walking common operations, such as process creation, image load, and thread creation. What I mean by this is in the kernel, I have a driver that registers notifications for whenever a process is created, whenever an image is loaded, and whenever a thread is created. And whenever, let's say, a process is created and through create process, I'll actually stack walk the user mode stack, and we'll be able to see what code led up to this process being actually created. And so this is a useful data source because, one, I can look for code that isn't mapped in a module, and two, I can find, let's say I know a process is bad, I can see what code actually started it. And so that's very valuable since I can find, if I know a process is bad, I can see exactly what code led to the execution of that process. For image load, same thing. This, I can detect remote library loading or even just local library loading. In thread creation, it's again remote and local. So whenever, let's say you manual mapped code or try to hide code in a process, if you loaded an image, started a process, or started a thread, and you weren't in a valid module, my Peacemaker threat detection platform would catch you and actually tell me exactly where you're at. Because it would, again, just walk the stack. And so, yeah, it detected remote thread creation as well, just because that's usually used in malware. And also parent process ID spoofing, where they try to hide what the actual starting process of a running process is. And so another functionality Peacemaker had was filtering. And so what filtering is, I allowed myself to block file system and registry write, delete, or execute operations that violate a filter I specify. For example, let's say there's a very sensitive RDP key, like F deny TS connections. What I can do is I can place a registry filter on that so that anytime any process tries to write to it, I'll not only deny it, but I'll be able to see what code led up to that write, what code actually tried to write to that sensitive key. And so this is what I did. So like for sensitive keys such as RDP-related ones, or for files sensitive, maybe it's my config file for a service, or even PowerShell itself. I would block execution of those files or modification, and at the same time log basically everything that led up to that execution. So this allows me, let's say that malware, they want to enable RDP, so they write to a registry key. Now not only have I detected that and blocked it, but I learned where the malware is hiding. And so there was definitely false positives with this one, and this allowed me to, the filtering platform allowed me to filter through those. And so here's some screenshots just showing, for example, we can see what process started another process. We see just basic process information, stack trace that led up to that process being created. There's also a list of loaded images, and I can click on any of those images that were loaded. I can see what code led to that image being loaded. So it was a really good data source for tracing down malware. And so in the next section, we'll be going into malware analysis of what I found and how different utilities that I had to detect malware were implemented. So one of the first things I detected, Peacemaker detected, was Cobalt Strike. I didn't know it at the time, but what I saw was that they were trying to connect to a server using the WinSock library. And what the problem was that for some reason, WinSock decides to create a thread whenever you connect to like a remote server. And so when that thread was created, Peacemaker looked at the stack. It saw that the highlighted red is where their code was hiding. It detected that there was some code executing that was not in a legitimate module. And so it said, stack violation alert. There's a thread creation, but it's not in a valid module. And so now I learned that, process ID 72 SUC host was infected with some sort of malware for sure. And so another example of that was that when I investigated what started the SVC host. because it wasn't linked to any services. It was plain old an SVC host running. And so what happened was I looked at the process ID using the process investigator. I saw that the parent was 3448, win subsystem.exe, and I was I don't recognize that in the Windows directory. I definitely knew that was probably malware. And I saw that the Win subsystem was just calling a start service and to start the SVC host, the malicious SVC host, and then maybe it would be injecting into it. And so this allowed me to learn Win subsystem malware and allowed me to respond to that pretty fast. But it wasn't just Win subsystem. They were hiding in multiple binaries for Cobalt Strike. And so, for example, we have another one where winlogon.exe tried to create a process called PowerShell. And so this caused two alerts because one, the stack leading up to this creation of PowerShell was invalid. Again, there was manual mapped / hidden code. And secondly, I put a filter on PowerShell because to block execution of that, a lot of people try to use it. And so that caused a filter violation alert as well. And I could see exactly what code led up to that execution from an SVC host. And so this was a very valuable data source because I could see, manual mapped code, not only that, but also I could see that whenever they executed PowerShell, I knew exactly what code that was executing that binary. And so the other WinRM trick that I went over earlier came in very useful as well because they tried to execute commands that would change my firewall. In this case, in the screenshot here, they tried to add an ICMP rule that would block incoming and outgoing ICMP. And so here we could see, again, SVC host and WinLogon, which I associated with the Cobalt Strike malware. In this case, it was blocked because they were not executing these commands through WinRM. Instead, they were just executing it straight from the infected binaries. So this definitely helped with some downtime because now I learned that they were trying to block it through the firewall. And the command didn't go through anyway, so I lost no uptime in that sense. Another data source here was that they were trying to execute Goose Desktop, which from WinLogon again. And so that, again, blocked it completely because it wasn't WinRM. Instead, it was their malware trying to execute it. So we had control over command prompt and PowerShell execution. Command prompt could only be executed through WinRM. And in this case, since it wasn't, it blocked it. And what happened after, during Saturday, between the competition days, I actually reversed the malware a little bit. I didn't realize it was Cobalt Strike at the time. I'm not that familiar with different types of malware in that sense. But when I looked into it, it was really interesting. So it started like a service control handler for the service DCE RPC SS. Then it created a pipe, a named pipe, where it would write XOR encrypted. I wouldn't really call it encryption, but XOR obfuscated data to this pipe. And then it would close that pipe and reopen it and read it in and decrypt it using another set of data. And then it would start the SVC host binary if it could and inject into that using thread hijacking. And so that allowed them to launch Cobalt Strike pretty simply. And since the AVs were disabled on the machine anyways, Windows Defender didn't pick it up or anything. But I just found it interesting that Cobalt Strike worked that way. I didn't know, and it's pretty interesting stuff there. So the next malware that I found through Peacemaker was this workstation.exe. When I looked at it, it was started by services.exe, indicating to me that it was actually a running service. So I looked under registry. I looked for what could be workstation.exe, what service is it. I found one called workstation SVC. So what they were doing is workstation.exe is actually Mimikatz. They recompiled it so it's not like Mimikatz.exe or Mimikatz in the strings. They called it workstation. And so what the arguments there, RPC server and then service me and exit do is RPC server launches it listens for an RPC connection, and this allows for remote connections to Mimikatz. And they can, like for example, dump my passwords completely remotely. The service me argument then created a service for itself, so it would always persist when started. And so that would make it harder for me to remove it. And then exit would just exit out of the program after all this was done. I realized pretty quickly that the binaries was just recompiled version of Mimikatz after looking up some of the arguments that was being executed with. And so again, it was just host an RPC server and persist by creating a service. That was the primary strategy for this Mimikatz rebuild. The next thing was I found through forensics was actually Professor Olson's malware. He used it last year as well. So I saw that there was a sysinternals.dll being written around 9:37 a.m. and I was very suspicious because I've never heard of a DLL called sysinternals that comes with Windows. I saw that was, he kept writing it over and over again. He once wrote it at 9:37 a.m. and then 9:58 a.m. And when I opened up the binary and it just said decompiler, I immediately thought it might have been Olson because it was like the PDB path for it was C users, ROB documents, and then ISTS 2019 leech implants. And so I decided to reverse it overnight again. It was really interesting because it was a little bit more, it was a definitely modified version from last year. For example, in this case, it created an Agent Smith user instead of just a normal, like I believe last year it was Colonel Sanders. And so this time it created an Agent Smith. For some reason, he also added a little bit of obfuscation to the password of Agent Smith. It turned out to be don't do bad things, one exclamation point. I confirmed it was Olson during a competition because when he was walking around, I think, to check if some of his other malware was running, I told him straight up, don't do bad things, one exclamation point. And his reaction was all I needed to determine that it was his malware. And so this malware, again, it tampered with the firewall. It started remote desktop. Also, interestingly, it disabled protected process on the LSAS binary, which handles like credentials. And so what it did was make LSAS a lot more vulnerable. And so this would do it whenever DLL was ran. There's some timeouts, and it would add Agent Smith as a remote desktop user and admin user every time as well. So in the end for Windows, all scored services were up and scoring that I had access to. Unfortunately, we didn't have access to the Tor network because there was just some trouble accessing that. And so there was no EANCAT on my box, which was really nice on the box that I had control of. And so I don't think Jamie's thing worked. It might have been the WinRM thing again. He might have just tried to execute it through Cobalt Strike. This blocked it. Peacemaker did its duty. I couldn't really expect it to perform any better. It told me what details I needed to know. And I definitely found some cool malware. I'm going to be looking into the Cobalt Strike a little bit more because you don't usually see binaries like that in the wild. So I might reverse engineer that a little bit more. So some lessons learned would be that to prepare earlier instead of just right after ICS competition, I crammed like a 3 to 4 month project into a 1.5 month time span, which definitely wasn't fun. I think that I should automate more because it's worse than I expected it to be for time management wise. I would do more templates for injects because there was a lot of injects that would happen, and I feel like some of them could have been made into a template. Work on time management again, just making sure during the competition I'm keeping on track of things and making sure not wasting time, and assume nothing because, for example, the WinRM thing, I didn't want to assume that, I assumed that since it wasn't on the packet, it wasn't a scored service. That's not necessarily true, or I assumed the topology would be the same in the packet, which is a bad decision again. I worked around it. So that's the end of my presentation. Here's some questions. You can access Peacemaker if you're interested in the source code at that link. It's public now. And yeah, that's it. Any questions? Owen?
Yeah, so you said you're going to automate things, but if you're not going to make any assumptions, what are you going to automate?
Well, that's a fair point. That's definitely a fair point. And so it's really automating what I've seen before. And you might say that's an assumption in itself, but assume nothing, and it means that I shouldn't really trust anything unless I should always have redundancies. So assume nothing, like even if I do prepare for automation, I should always have a backup plan in that sense.
Can you just repeat his question real quick?
Yeah, so Owen asked, so you mentioned automate everything, but then you also said don't assume anything. And so my response again to that was that that's true, but there should always be redundancies where you should automate as much as you can. But if that fails, you should be prepared for that to fail. And you should try to work around those problems. Any other questions? Yes, Adler.
So you enable test signing, test mode.
I did not enable test signing.
Really?
Yes.
So how do you even get your kernel drivers loaded?
Because I have a kernel code signing certificate.
Do you really?
Yes.
Oh, shit. Wait, yeah, what the fuck? So how long did that take you to get?
Sorry?
How long did it take you to get? Through the whole process?
Oh, through the whole process, probably like a week.
Really?
Yeah.
Like, did you already have an LLC?
No, I didn't use an LLC. I just made a sole proprietorship with my town over Christmas break, and then in 2 days, I got my certificate from Sectigo.
Okay.
No, you have to have like a company,
Yeah.
but it could be like a sole proprietorship in that sense. They just need to be able to verify your identity.
Interesting. Okay. All right, good stuff.
All right. Thank you.